AP Cram, Calculus AB, Free Response Exam Review. Question 57. Rate of change, first derivative. Alright, so hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t, where t falls between the closed interval of 0 to 6 minutes, is given by the differentiable function c, where t is measured in minutes, as I just said. Selected values of c of t, measured in ounces, are given in the table above. Alright, so the amount of coffee in the cup in ounces is modeled by B of t equals 16 minus 16 times e to the negative 0.4 t power. Using this model rather than the table, find the rate at which the amount of coffee in the cup is changing when t equals 5. The solution to this is really straightforward, but if you don't know how to have a certain skill, it might be a little difficult for you. I'll give you a moment to think. All right, so whenever you're asked to find the rate at which some amount is changing, these are code words for differentiate. The derivative, the first derivative that is of a function is the rate of change. Okay, and then the second step you can take is to go ahead and evaluate it at the initial condition 5 minutes. So we're going to differentiate the function b of t. So what we're going to do, as shown here, is find the derivative of b of t via implicit differentiation. So d dt, the derivative with respect to t of b of t, equals d dt of 16 minus 16 times negative raised to the 0.4 t power. What I recommend you do is just plug this into your calculator, not the left-hand side. Just, the function to be 16 minus 16 times e raised to the negative 0.4 t. Just take the derivative of this in your calculator and then evaluate it at 5. In case you don't know how to do that, I don't know, like YouTube or Google a vid for that. Or I can show you how to do it sequentially, step by step. All right, so let's do this. So the derivative of b of t is b prime of t. So this is the same as this. This is the shorthand version of d dt of b of t, okay? All right. So now we're going to differentiate each term by term and factor out constants. So we distribute the first term and the second term, and we factored out the constant 16 in the second term. Now we know that the derivative of 16 is 0, expressed here, so we can just ultimately eliminate that. And this is what we're left with, negative 16 d dt e times e ddt of e raised to the negative 0.4 t power. Okay, now this is the tricky part that trips a lot of people up. But again, you should not be doing this by hand on the actual AP exam. It should all be input into your calculator. I'm just showing this process for people who want to know all the sequential steps in this particular differentiation, but I don't recommend you actually do it on test day, okay? All right, so the part that trips people up is the chain rule. And we're going to have to use the chain rule to differentiate e raised to the negative 0.4 t power, and we're going to perform u substitution. So the u is going to equal negative 0.4 t, and then if we take d du of e to the u, we know that the derivative of e raised to the whatever is just going to be the same exact expression, e raised to the whatever. And then the chain rule says that we also have to multiply by the derivative of the inner term, okay? So this is what we end up with. We end up with a negative 16 times d du, the d du of e to the u, which is just going to be e to the negative 0.4t, because I just said we're allowing u to be 0.4t. And then whatever u is, we also have to multiply by the derivative of that inner function, okay? All right. Now, a second time, we're going to factor out constants. So this is multiplication here, not subtraction. We're just factoring out negative 0.4 out of d dt of negative 0.4t. And all we're left with to differentiate is the term t, okay? And we can just go ahead and multiply negative 16 times negative 0.4. And, well, if you don't know how to do this, you can just say to yourself, well, 4 times 16 is 64. So a negative 16 times a negative 4 is going to yield a positive 6.4 because we just shift the decimal place one space to the left, okay? Therefore, b prime of t equals 6.4 e raised to the negative 0.4t, sorry, times the derivative with respect to t of t. And we know that if we take the derivative of t, that's just going to give us 1. So we can just go ahead and simplify our expression. And b prime of t, or the rate at which the amount of coffee in the cup is changing in general, not at t equals 5, is going to be represented by this 6.4 times e to the negative 0.4t. Now what we can do is go ahead and plug in 5 for t, and we're going to have e raised to the negative 2 power, so e squared, okay? And when we go ahead and do that, we're going to end up with a value of 0.866146 ounces per minute, okay? So that's our rate of change. And you just have to do your ounce. To be more accurate, you have to do your fluid ounces, OZ, shorthand for fluid ounces, and the time unit is going to be minutes. Sorry for the time lag with my scribble.